Among the term symbols 4s1, 2d 7 by 2, 3s1 and 2d 5 by 2, choose the options possible in the LS coupling notation. So we have to find which among the notation is a possible LS coupling. First we will write the term symbol. Term symbol is 2s plus 1 LJ. Okay. So we will take the first option A. A 4s1. Here L is equal to 0 and 2s plus 1 is equal to 4 implies s is equal to 3 divided by 2. Therefore, j is equal to 0 plus 3 by 2, that is 3 by 2. So for this value of L and S, j value must be 3 by 2. But in the question they have given j value as 1. So this is not the possible notation. Second one, 2d 7 by 2. Here L value is 2. 2s plus 1 is equal to 2. This implies s is equal to half. So j value is 3 by 2, 5 by 2. So in the question they have given the j value as 7 by 2. This is not the possible value. So B is also incorrect notation. C 3s1. Here L value is equal to 0. 2s plus 1 is equal to 3. This implies s value is equal to 1. And so j value is equal to 1. So in the question also they have given 1. So this option is correct. D 2d 5 by 2. L value is equal to 2 and 2s plus 1 is equal to 2. So this implies s is equal to half. So the possible j value is 3 by 2 and 5 by 2. In the question they have given 5 by 2. So this is the correct option. So answer is C and D. The transition line as shown in the figure arises between 2D 3 by 2 and 2P 1 by 2 states without any external magnetic field. The number of lines that will appear in the peak presence of a weak magnetic field is. So in the question they have given a transition from 2D 3 by 2 to 2P 1 by 2 state. So they have asked us to find how many lines will be there if it is being given a weak magnetic field. Right? So it is a weak magnetic field. So it is an anomalous Zeeman effect. So the selection rule for it is delta mj is equal to 0, plus or minus 1. And if j is equal to 0, the transition of mj 0 to 0 is forbidden. Okay, and the possible value of delta j is 0, plus or minus 1. And also j to j transition is not possible. Okay, now in the question they have given 2d 3 by 2 and 2p 1 by 2. So the possible mj value is minus 3 by 2, minus 1 by 2, 1 by 2 and 3 by 2. And for this state the possible mj value is minus 1 by 2 and 1 by 2. Based on the selection rule, the possible transition is from minus 1 by 2 to minus 1 by 2 state, and minus 1 by 2 to plus 1 by 2 state, plus 1 by 2 to minus 1 by 2, and from 1 by 2 to plus 1 by 2. and from minus 3 by 2 to minus 1 by 2, 3 by 2 to plus 1 by 2. So only these are the possible transition based upon the selection rule. So the number of spectral line will be 1, 2, 3, 4, 5, 6. This is one way of calculating the value, and the other way is J1 value of one state is 3 by 2 and J value of another state is 1 by 2. So the number of spectral line Nt is equal to 3 into N pi. So where N pi is equal to 2J plus 1, and here J is equal to minimum value of J1, J2. We have to take the smallest value. So 2 into, it will be half plus 1. So the value of J is 2. Now substitute the value here, N pi value. Nt is equal to 3 into 2, that is equal to 6. So the answer can be obtained in both the ways. Answer is 6. The coulombic energy component in the binding energy of a nucleus is 18.432 MeV. If the radius of the uniform and spherical charge distribution in the nucleus is 3 Fermi meter, the corresponding atomic number, and given E square by 4 pi epsilon naught is 1.44 MeV Fermi meter. So in the question they have given the coulombic energy component of a nucleus is 18.432 MeV, and also they have given the radius of the nucleus. They have asked us to find what is its corresponding atomic number. We know that the coulombic energy component for spherical distribution is EC is equal to E square divided by 4 pi epsilon naught 3 divided by 5 Z square divided by R. In the question they have given EC value as 18.432, that is equal to, this value is given in the question as 1.44 into 3 by 5 into Z square by R. R value is 3. So this 3 and this 3 will get cancels off. So Z is equal to root of 18.432 into 5 divided by 1.44, that is equal to 8. So the atomic number corresponding to this binding energy and this radius is 8. Assume that 13 nitrogen undergoes first forbidden beta plus decay from its ground state with spin parity J initial pi to final state. The possible values of initial state and final respectively are. So in this question they have taken a nitrogen, and this nitrogen undergoes a first forbidden transition. Okay, they have asked us to find what is the J and parity value of initial state and also the final state. So 13 nitrogen, in this here the total number of proton is 7 and for neutron is 6. So according to shell model, we have for a nitrogen we have 1s half, 1p 3 by 2, 4 and 1p half 1. So here this is the corresponds to the ground state. So the initial state Ji pi will be, so J value is half and pi value is minus 1 the whole power L. Here L value is 1, so minus 1 the whole power L is equal to 1 divided by 2 minus. So this is the initial state. If you see the option B is incorrect and option D is also incorrect, because here the parity is given as plus. Okay, we have to find only the final state. In case of first forbidden beta plus decay, there must be a change in parity. Okay, now if you see the option, in option C, there is no change in parity. Only in option A, there is a parity changes there. So answer is option A. A linear charged particle accelerator is driven by an alternating voltage source operating at 10 MHz. Assume that it is used to accelerate electrons. After a few drift tubes, the electron attain a velocity 2.9 into 10 raised to 8 meter per second. The minimum length of each drift tube in meter to accelerate the electrons further is. So in the question they have taken a linear charged accelerator, particle accelerator, and they are operating at an alternating voltage frequency of 10 megahertz, and they have accelerated the electron to a velocity of 2.9 into 10 raised to 8 meter per second. Second, they have asked us to find what is the minimum length of the each drift tube. So we know that in case of a linear accelerator, under resonance condition, the time taken by the ion to transverse through the drift tube is equal to half of the time period of the RF accelerating voltage. Okay, this is the important condition in order to accelerate any particle in a linear accelerator. So in the question they have given the frequency of the alternating voltage as 10 megahertz and the velocity attained by the electron is 2.9 into 10 raised to 8 meter per second. They have asked us to find length of the drift tube. So time taken is nothing but length of the drift tube L divided by velocity of the electron is equal to T divided by 2. This implies L is what we have to find. 2.9 into 10 raised to 8 is equal to time period T is equal to 1 divided by F. So you will be getting 1 divided by 2 into 10 raised to 6 into 10. So L is equal to 2.9 into 10 raised to 8 divided by 20 into 10 raised to 6. That is equal to 14.5 meter. So this is the length of the drift tube. The spacing between two consecutive S-branch lines of the rotational Raman spectra of hydrogen gas is 243.2 centimeter inverse. After excitation with a laser of wavelength 514.5 nanometer, the Stokes line appeared at 17611.4 centimeter inverse for a particular energy level. The wave number at which Stokes line will appear for the next higher energy level is. So in the question, they have given the spacing between the two consecutive S branch lines of rotational Raman spectra as 243.2 centimeter inverse. That is for a S branch, the lines occurs at 6B, 10B, 14B and so on. So the spacing between the two successive line will be 4B. That is given in the question as 243.2 centimeter inverse. So from this we can calculate what is the value of B. B is 60.85 centimeter inverse. They have used a laser source of wavelength 514.5 nanometer and they have seen a Stokes line at 17611.4 centimeter inverse. Okay, now they have asked us to find what is the Stokes line for the next higher energy level. So for this Stokes line we have to find what is the J value and then we have to find the next higher J value, that is we can have it as J prime, and then we have to find what is the value of the Stokes line, what position it will appear. So first for the given Stokes line we will find the J value. So the Stokes line is given by excitation wave number minus B into 4J plus 6. Okay. So this value is given as 17611.4. That is equal to, in the question they have given the wavelength of the excited source. So the corresponding wave number will be 1 divided by the wavelength 514.5 into 10 raised to minus 9. So this will give a value of 19436.3 centimeter inverse. So now we can substitute it here, 19436.3 minus B into B value we have found, that is 60.85 into 4J plus 6. So by simplifying it we will be getting 60.85 into 4J plus 6 is equal to 1825. Then 4J plus 6 will be is equal to 29.99. So we can write 4J plus 6 is approximately equal to 30 we can write. So from this we will be getting J value is equal to 6. So for the given Stokes line the J value is 6. So the next higher energy level will have a J value of 7. Now we have to find what is the wave number. In terms of wave number we have to find. So Stokes line is equal to 19436.3 minus 60.85 into 4 times of 7 plus 6. So by simplifying it we will be getting 17367.4 centimeter inverse. The Gelman-Okuba mass formula defines the mass of the baryon as m is equal to m naught plus ay plus b I into I plus 1 minus 1 by 4 y square, where m naught, a and b are constants. I represents the isospin, y represents the hypercharge. If the mass of sigma hyperon is same as that of the lambda hyperons, then the correct options is R. A. M is proportional to I into I plus 1. B. M is proportional to Y. C. M doesn't depends on I. D. M does not depend on Y. In the question they have given a mass of baryon formula, and also they have given mass of sigma hyperon is equal to mass of lambda hyperon, and they have asked us to check which among the 4 option is correct. Okay, first we will write the given formula. M is equal to m naught plus a y plus b into I plus 1 minus 1 by 4 y power 2. Right? So first we will find mass of sigma. Mass of sigma is equal to m naught plus hypercharge of A into hypercharge of sigma plus B into isospin of sigma into isospin of sigma plus 1 minus 1 by 4 times of hypercharge of sigma, the whole square. Right? So for finding the mass of sigma we need to know the value of isospin and the hypercharge of sigma. So first we will find that. Hypercharge is equal to baryon number of sigma plus the strangeness of the sigma. So that is 1 plus minus 1. You have to memorize the baryon number of sigma and the strangeness of a sigma. So you will be getting 0. And isospin of sigma is equal to 1. Now substitute the values of y and I in the mass of sigma. So you will be getting mass of sigma is equal to m naught plus a into 0 plus b into 1, 1 plus 1 minus 1 by 4 times of 0. Right, so you will be getting simply m naught plus 2 times of b. So this gives the mass of sigma. In the similar way, we will find what is the mass of lambda. It will be m of lambda is equal to m naught plus a into hypercharge of lambda plus b into isospin of lambda into isospin of lambda plus 1 minus 1 by 4 times of hypercharge of lambda square. And hypercharge of lambda is equal to baryon number of lambda plus strangeness of lambda, that is equal to 1 plus minus 1, that is equal to 0. And isospin of lambda is equal to 0. Now we have to substitute both the values here. So we will be getting m of lambda is equal to m naught plus a of 0 plus b of 0. So this implies mass of lambda is equal to m naught. Right? It is given in the question mass of sigma is equal to mass of lambda. Right? So we can equate this equation and this equation. So we will be getting m naught plus 2b is equal to m naught. So this implies the constant value b is equal to 0. Right? Now we can substitute b is equal to 0 in the given mass of baryon formula. So in this formula we will be getting m is equal to m naught plus a into y. This is the formula that we have obtained finally. Now we can say this mass is proportional to y. Right? So option B is correct. And in the similar way, the mass of the baryon does not depends upon isospin. So this option is incorrect. And also that is mass does not depends upon I. So this option is correct. And also mass does not depends upon y is also an incorrect option because m depends upon y. So answer is option B and C. For the given sets of energy levels of nuclei X and Y whose mass number are odd and even respectively, choose the best suited interpretation. In the question, they have given two sets of energy levels, set 1 and set 2. And they have given two nuclei. It corresponds to a nuclei of X and Y. In the question, they have asked us to find to which nuclei the sets belong. Okay, so we have studied in collective model the vibrational levels of even nuclei. Yes, ground state is 0 and the first excited state is 2 plus and the next state is 0, 2 plus, 4 plus. Now if you see the given set, we can say set 1 corresponds to a vibrational band. Therefore, option A and option B are incorrect because it says set 1 is a rotational band. Now we have to check whether this vibrational band corresponds to X or Y. This corresponds to an even nuclei. In the question they have given Y corresponds to a mass number of even. Therefore, Y nuclei corresponds to the vibrational band. And set 2 is a rotational band of X. So answer is option D. The spin orbit effect splits the 2p to 2s transition in lithium into two lines with separation of delta lambda is equal to 0.14 Armstrong. The corresponding positive value of energy difference between the above two lines in electron volt is m into 10 raised to minus 5. The value of m rounded off to nearest integer is. In this question they have given because of spin orbital effect splitting happens in a lithium and the difference between the two level have delta lambda of 0.14 Armstrong and they have given difference in energy is m into 10 raised to minus 5. So delta lambda is equal to 0.14 Armstrong and delta E is given as m into 10 raised to minus 5. And lambda is given in the question as 6521 Armstrong and they have asked us to find what is the value of this m. Okay, so we already know E is equal to hc divided by lambda. So delta E is equal to hc minus 1 divided by lambda square into delta lambda. So in the question they have said only for the positive value of energy difference. So delta E is equal to hc divided by lambda square into delta lambda. As they have given positive, we have removed the negative one and we are calculating only the positive value. So in the question they have given already delta E is m into 10 raised to minus 5 and H is 4.125 into 10 raised to minus 15 and C is 3 into 10 raised to 8 divided by lambda is 62521 into 10 raised to minus 10 and delta lambda is 0.14 into 10 raised to minus 10. So by simplifying it, we will be getting m value as 4.08. In the description box, you can find the solution for GATE 2018, 19 and 20 question paper. Please share and subscribe the channel.